Thank you so much, Chris. I feel like you've laid down the gauntlet for us in our conversations for the next 3 days. So perfect opening. In terms of asking questions, if you're in the room and would like to ask in person, I'll bring you the mic so that the people online and so on will be able to hear as well. And if you're online, the chat is open and it's waiting for you.
Thank you, Alison. Will Cluett, Chemical Engineering, U of T. That was great, Chris. There's so much there for a much broader audience, especially that future of work. I think those slides can be shared, very, very widely. Just a local little story related to automation. We're having a big strike in Vancouver right now at the Port of Vancouver, which is all related to labor pushing back against automation. It's very interesting that is a current big story in Canada. The other thing I just wanted to say in chemical engineering, automation has been around a long time. If you go back to the OPEC crisis, oil crisis in the 70s, that's really what drove automation in the oil and gas industry. So that's 50 years ago. So what's changed? Automation, it's been around, but why now is it just seem to be omnipresent? Is it just that it's percolated into every aspect of life?
I think it's the things have come into the sort of the knowledge type sphere. Just the technology, when it came to scale. If you think about something that's just trying to predict to the next word, what somebody, given what I know and what's this person going to say next, and then you put a bit of randomness in that, you make it a probability distribution of what they're going to say next. And so the idea that it could do something really important and good, not good in a moral sense, but effective, would seem laughable, right? And it wasn't really until it got scaled, till it had enormous amounts of parameters, enormous amounts of information, that things started happening that surprised all the people who made these things. And it's just happened recently. That coming together just happened recently. But talking about what's happened with chemical engineering, I've just come from Sarnia and I know what's happened in Chemical Valley. All those companies are gone.
There's nothing in the chat from our online folks. Is there? Thank you.
Thank you for the interesting talk. I was wondering if you could please elaborate on that part where you said, I'm not sure if students get this, internalizing knowledge leads to creativity. That knowledge piece, is that learning the mechanics of the car or learning how to drive the car? What needs to be internalized?
All things need to be turned on, depending what the purpose of the person doing. If they're learning to be driving the car, they need knowledge that will let them think about how to drive the car more effectively. If they're trying to build something, they need knowledge, internalized knowledge about that. Basically, it's just the idea you need relevant things in here to connect to get to any insights.
But should we still teach them the classics or the classical statistics and all those methods?
I think we should teach a portion of people those classic things. Yes, the ones who you think are going to be capable of going on and making new things for themselves.
All right.
I think much less for everybody else.
All right. Thank you.
I think the question I had actually was just, I feel like I've got a beautiful segue. A few years ago, you and I were part of a group that was thinking about a data science curriculum for schools. And one of the things we were thinking about is that data science felt like an opportunity to open up STEM for a much larger audience.
Yeah.
And then I've been thinking about generative AI in the same way.
Yeah.
And I wondered if you were able to make any connections in that direction.
No, we had some reasonably good ideas then. They've all gone to naught because COVID came and all of the people who were working went other places. But no, I think I will leave that for the next 3 days, Alison.
Anybody would like to talk to us about it? Yeah.
Hi, Chris. Thank you very much for a lovely talk. You said students are really expecting predictable ways of learning, predictable assessments and everything.
Not only students, university systems are imposing it.
That's what I was going to say. It's not just students, it's
Yeah.
not, academics are forced to do that. I mean, let's say in my university, we are advised to increase student success. We need to give them questions prior to exams that are very similar to what they're going to see in the exam, so they know how to solve. So it's not the thinking so much, but the procedures.
Yeah.
And what kind, so when you ask something out of the box, which they haven't seen before, but they should be able to figure out with their knowledge, connecting the dots, things like that, we get many, many great appeals. I haven't been taught to do that.
Yeah.
What do you do with that?
I've got this thing. I'm retired.
What do I do with that?
Alison is right at the forefront of these things. Maybe you could. Yeah.
I mean, there are really great ways of teaching and assessing and engaging students, absolutely. When I have 30, 40 students, it's
Yeah, yeah, yeah.
possible.
Yeah, yeah.
But when I have 1,500 students, I don't even know who they are.
Yeah,
They're just
yeah.
numbers,
Yes.
and for university, they're just dollar signs. So that's about
I
it.
think systems are fighting us rather than helping us, yes.
For those of you that don't know the University of Toronto, we have over 4,000 students enrolled in statistics programs of study. So if any of you, rest of you are struggling with large classes and large sizes, find one of our U of T folks. We'd be happy to chat.
Hi there, congratulations on your retirement. Could you please look into the future and tell me what the people in the room for IASE 2033, 2043 are doing, what their articles look like? How is the change that you're talking about impacting the people that are here today?
I should have made my talk longer and then I wouldn't have got so many of these questions. What will people look like? Well, I think the main thing that's unifying the people in the room right there are people who care about making education more targeted, better, more effective. I think that'll still be happening in 30 years. What each of those things looks like in another 10 years, I haven't had a clue. But I think our community will still be trying to do the same sorts of things in a slightly different environment. Well, in maybe a much different environment.
Anybody have a question or an answer?
Yeah, time for answers now.
It's very difficult now. Once you put so many challenges in my mind, it's hard to think about it. But what I'm thinking about is the responsibility lies on our own shoulder, or is it somewhere else? Because some of the things we cannot do ourselves anymore. Some directions that I can think of and were not mentioned in your presentation and might be mentioned in the future are the following issues. One of it is interdisciplinarity. The world is getting more complex and therefore classes should look like not a statistics class, but rather a statistics, science, mathematics, social sciences, etc., in the same ecology somehow. I don't know how to do that. I have a clue. I will be talking about it in 2 days, but I only have a clue about what it should look like.
Yeah.
Another direction has to do with the term authenticity. So the authentic levels of traditional class is very low usually. So we need to somehow make classes look like a real world business. And the more authentic, and there are different authentic types of thinking that should be taught. It could be the scientist authenticity, it could be the student authenticity, it could be a few disciplines, different authenticities, visiting in the same class, and so on and so forth. With imagination, I find it very hard to think about, because in one of your slides you said, let's populate the mind with imagination or something like
Possibilities, yeah.
Yes, and I'm not
I'm trying to-
sure, I'm not sure that you can do that with imagination. I agree that people who have imagination
Oh, no.
needs to know a lot, but whether I can help them do that, I do not know how to.
No. My thing wasn't populate. It was populate their.
Anyway, with imagination.
No, it wasn't imagination. It was their, what they're aware of with possibilities. In other words, make them aware of possibility. I mean, and also the process of becoming aware of possibilities. But yeah. No, I can see all these things are worthy, but in our world, we have to make changes where we can, and I think we're a little bit like plants in the desert. We're sort of trying to grow here somewhere, and then maybe sometime we can find somewhere where we can get some roots in and try and make something a bit better. And I think sometimes we have to be not trying to do all things at all the time, but doing the things that we can see a way of implementing, of making work. And I agree that doing things in collaboration with other people, so people see different sort of inquiry styles, thinking styles all coming together, that creates lots of great awarenesses on some dimensions. But I also think that it won't do the things that are internal to a strain of thought. So yes, we need broad experiences for some things, and we need sort of semi-linear experiences for other things, just so it's possible to actually link the things together.
Thanks. We're quickly running out of time, so I'm going to let Larry give us one more thing to think about. I'm glad we've got the next 3 days to keep unpacking these ideas. And then we'll shut down the Zoom session. It'll be the coffee break. I do have a few really quick announcements for folks attending in person just to help us navigate the space.
Yeah, just in the theme of, what can we do practically and with all the constraints that teachers of statistics have. One of the things that teachers sometimes have flexibility with is setting the exam. And so that really, if you change the emphasis in the course from the things that robots can do, like calculating things, to, for example, instead of just talking about calculating p-values, talk about the fact that when you get a surprise, you actually learn something. That's an idea that you can kind of transfer, or if you're looking at residual plots, not how to do it, but the fact that when you see how the model is wrong, I actually learn something that way.
Yeah.
So that's another principle. So these set of principles, you can actually set exam problems that test these principles. The students hate them, of course. But they have to understand something to be able to answer those questions. So I was thinking of a practical thing that teachers can do right now if they have, access to setting the exam, would be to, try and move in that direction. What do you think?
I think, I think all those things are true. I think that, just a minute, an idea's come and gone. I think, so one of the ideas that's come and gone is one thing that will actually, I think, delay AI making big inroads in some of the things we do are in things like graphical interpretation. And I think some of the reasons that'll be hard for the AI is some of the things that we've done badly ourselves, because we have had this culture that when you learn about something, you do one or two examples, which is fine for operating a procedure. But when you're trying to learn to spot things, then you need heaps and heaps of examples about doing it. And we haven't been doing that. And the good side, there's nothing there for the AI to pass on into. So I think statistical graphical interpretation might be a wee bit slow. Whereas I think things like sort of in interpreting numerical outputs are much more mechanical and probably can be done a lot faster.
Thank you so much, Chris, and I'm so sorry I have to stop the conversation now.
Okay.
Thank you.